Hello and welcome to Rationals 2.1, one rational expression. Okay, so today we're going to solve for x, and we're going to use some of the things that we've been doing in the previous couple of lessons, like matching the denominators, except this time when we match denominators is not going to be for the purpose of adding or subtracting fractions. It is not going to be for the purpose of LCM or anything like that. I mean, we're going to use those techniques to get to the final answer when we solve for x, but we're gonna go in a different route. So if you guys look in the handouts that I gave you guys, it's gonna give you guys a different technique from the one I'm gonna show you guys right now. So you can do the one in the handout, that's fine. But this one is actually the better technique if you want to keep things consistent, because eventually when we do Rationals 2.2, you're going to find out that you're going to do the exact same technique that we're doing now. And this technique is going to be based on things like LCM, that we've been doing in the past couple of lessons. So it's going to seem more consistent as far as what we've been doing. So up to you though. The technique in the handout is a lot easier, but this technique that we're going to do now will keep things consistent. So you guys won't have to memorize like 3 different techniques to do all these different things that we're doing in the next couple of lessons. So up to you. You make the choice. All right. So first things first, let's do our restriction. And restrictions are going to be the numbers we're not allowed to have for x, right? And since we don't want to have a 0 on the bottom of the fraction, we're just going to try to imagine what number can I plug in for x so that when it combines with -3, it creates 0. Okay? And we're going to test out a whole bunch of numbers, and we're going to finally realize, I think a 3 in place of that x will make the 3 minus 3, which is going to cause a 0 to be on the bottom of the fraction. So let's avoid 3 at all cost. Okay? So, right, so let me erase this 3 right here so it doesn't mess us up for the rest of the problem, but we found our restriction. And there's only one number for now. Unless we have more x's appear on the bottom, then we're probably just going to have one restriction for the time being. Okay? So, let's write out my original problem. So we got 4 over x minus 3 equals 7 over 1. Let's make everybody into a fraction. Okay, and we're gonna do the same thing that we've been doing in the previous couple of lessons, where we're gonna match our denominators, and we're just gonna basically say, okay, does everybody have the same things on the bottom? Because if they don't, then we better give it to each other. Okay, so does the left side have a 1? The left side goes, no, I don't have a 1. So let's give the left side a 1. So we don't really have to give the left side a 1, but to make everything match perfectly, where both sides have the exact same elements or binomials or numbers or whatever you want to call them, right? Let's just do this for the sake of the story. Okay, so both sides have a 1 now. And the right side fraction, he's going to need an x minus 3. So let's do that. Let's give the right side an x minus 3. And we don't want to just give the bottom an x minus 3. We got to give top and bottom x minus 3. Okay? All right, so now that we have all the bottoms matching, right? They both have a 1, and they both have an x minus 3. Here's where you're gonna kind of get a little like frustrated, because you're gonna be like, what? We just did all that hard work to get the bottoms to match, and you're gonna do this as your next step? And my response is, yeah, we're gonna do this as my next step. And you're gonna go, why? And I'm gonna say, because it's gonna make your problem overall a lot easier. Okay, so that's your main idea, right? We're doing all this humbug stuff, like making your denominators match, because in the very next step, the problem is going to get way easier looking. Okay, so because they both have the same denominators, right, and they're on 2 sides of the equal sign, right, they're on opposite sides of your equal sign, then you're allowed to just cross them all out, cross out all the bottoms. So basically, you're canceling out the bottoms. Yeah, and when I cancel out all the bottoms, then all I'm left with is 1 times 4 up top, which is 4. And equals 7 times x minus 3. Okay, so we're just going to continue with this process. We're going to distribute the 7, so we're going to get 4 equals 7x minus 21. And then we're going to solve for x. So we're going to add 21 on both sides. And we're going to get 25 equals 7x. Then divide by 7. And we're going to get x equals 25 over 7. Okay, so we're supposed to check our answer, but not in the typical way that I showed you guys in other lessons where we have to have the two sides match. We're not going to have to do that. I mean, you can if you want to, but I'm not going to make it mandatory. Okay, so here's how we're going to check our answer. We're just going to basically ask one question. Okay, so we're going to realize that our restricted number is 3. So all we're going to do is we're going to go to our answer for x, which is 25 over 7, and we're going to ask him a simple question. And here's the question. Are you a 3? And he's going to respond, I don't think so. I'm a 25 over 7. So I don't think I'm a 3. And we're going to say, okay, cool. Since you're not a 3, then as long as we did our work up here correctly, the computation correctly, then you should be legit and good to go. Okay? A lot of your teachers may not like that you're going to check your work this way, but here's what we're going to just trust. We're going to trust that you did all your steps correctly, right? You got your bottoms to match perfectly. You distribute the 7 correctly. You solve for x correctly. So if you can assume that we solved all that stuff correctly, we did all those steps correctly, then you don't really necessarily have to check your answer. Maybe your own personal teacher is going to say, yes, you do, and don't listen to the person on YouTube. But yeah, as long as you can trust your work, you just got to ask that one question, are you a 3? And he's going to say, no, I'm not. So therefore, your answer is good to go. Okay? All right, so let's do the next problem, number 2. All right, so let's do our restrictions. So what number can we, or do we need to avoid because it's going to make a 0 on the bottom? So we're just going to say, well, what number do I put in place of x that when it combines with -1, it makes a 0? And you're going to say a 1 does that. So we better avoid 1. Okay, so is there any other number that I need to avoid? I don't think so. So let's erase the one over there because I don't want it distracting things. Oops, that wasn't an eraser. That was a pen. Okay, now it's an eraser. Okay, so let's write out our 2 fractions. So on the top we got x plus 5. I'm going to put that in parentheses. On the bottom we have 3 times the quantity x minus 1. And then equals 4 over, and here's where it's going to get a little different. I'm not going to write 9, I'm going to write 3 times 3. Because you got to remember, yeah, I want to make sure everybody has the same exact things as everybody else. Okay, so the left side fraction looks over at the right side fraction and he says, whoa, you have 2 3s. I only have 1 3. So because you have 2 3s, well, I want an extra one just like you. So we're going to give the left side fraction an extra 3. So now he has 2 3s, just like the other side. And then the right side fraction is going to look at the left and is going to say, whoa, you got an x minus 1. I don't have that, so I better go and get one also. So we're going to give the right side fraction an x minus 1 also. And we're going to give it the top and bottom, just to be fair, right? That's the rows of fractions. Whatever you give to the bottom, you got to give to the top. Okay, so now everybody has the exact same things on each of the bottoms, right? They both have 2 3s, they both have an x minus 1, they all match. And what's going to happen in this next step? The whole entire bottom is going to get canceled out. So it's kind of like you're multiplying both sides by 3 and 3 and x minus 1. And when you do that, it's going to cancel out all the bottoms. Right? Because that's what's the rule for doing things with an equal sign when you're solving. Whatever you do on one side, you got to do to the other. So if I multiply by 3, 3, and x minus 1 on both sides, all your bottoms cancel. So that's actually the real reason why the bottoms can cancel. We don't just cross them out just to cross them out. We cross them out because it mathematically works. Okay? All right, so let's continue solving. So on the left side, we have 3 times x plus 5. And on the right side, we have 4 times the quantity x minus 1. Okay, then we're going to distribute. So we're going to get 3x plus 15 equals 4x minus 4. Okay, so let's start gathering the letters on one side, the numbers on the other. So let's subtract 3x and let's add 4. Okay, so hopefully I'm doing all the math correct, because if I am, then I don't really have to check my work totally. Okay, so I get 19 on the left side, I get x on the right side, and I'm going to hope that I did all the work correct. I'm just going to do a quick check. 3x plus 15, 4x minus 4, minus 3, add 4. Yep, looks good to me. So to check our answer, we're just going to do one thing. We're going to go to the 19, right? The answer x equals 19. We're going to ask them one simple question. And this time our restricted number is a 1. So we're not going to ask the same question as the previous problem because the restricted number in the previous problem was a 3. So this time the question we're going to ask is, are you a 1? And 19 is going to say, I sure am not. I'm a 19. So therefore this answer, as long as we can trust that we did all the problems correctly and solved it and solved for x good, then we can trust that our answer 19 is legit and good to go. Okay? All right. Last problem, I think. All right, so let's do our restricted numbers. So I think we better avoid 2 because 2 minus 2 makes 0, and we better also avoid 3 because 3 minus 3 makes 0. So my restricted numbers are 2 and 3. Okay? So let's erase the 2 and the 3 so it doesn't confuse us, and let's write down the original problem. So we got x plus 7, put it in parentheses, over x minus 2, x minus 3. And all of that equals 1/2. Okay, so the left side fraction looks over at the right side fraction and says, oh, you got a 2. Let me get one of those. So he goes on and gets a 2. Okay. The right side fraction looks over at the left and he says, wow, you got an x minus 2? I don't have that. So we say, don't worry, we'll give you an x minus 2. So the right side fraction is happy. But he also notices that he doesn't have an x minus 3. So he said, hey, still, don't worry. We got you covered. We'll give you an x minus 3 also. And the right side fraction is going to go, wow, thank you. You're so nice. Okay, so now we got everybody having the same exact denominators, right? Both sides have a 2. Both sides have an x minus 2. And both sides have an x minus 3. So because everybody has the same matching denominator, we can just cross it all out. And we get 2 times the quantity x plus 7, and we get equals 1 times the quantity x minus 2 times x minus 3. So that 1 that's in the front, that's not really going to make a difference. So I'm going to just ignore it in my next step because 1 times anything doesn't make a change anyway. Okay, so we're going to get 2x plus 14 on the left side. And we're going to FOIL the right side, and we're going to get x squared minus 3x minus 2x plus 6. Okay, and since this is an x squared type problem, we got to make sure we're going to get everybody on one side. We're going to keep the x squared positive, and we're going to use factoring or quad formula or complete the square to get our answers of x. Okay, so let's combine like terms first on the right side. So we get 2x plus 14 equals x squared minus 5x plus 6. Okay, and then since the x squared is positive on the right side already, we're going to gather everybody on the right side, and my 0 is going to be on the left side. So let's subtract 2x on both sides, and let's subtract 14 as well on both sides. Okay, so left side we get our 0. Right, because that's one of our goals when we solve for a problem that has x squared. We want to get everybody on one side equal to 0, and we want to make sure x squared stays positive. So we've covered all those bases, and now we're going to solve this by either doing factoring, complete the square, or quad formula. And I think we can factor it, yeah, because I think we have two numbers that can make -8 when I multiply and -7 when I add. Okay, what combination of numbers is that? I believe it is x minus 8 and x plus 1. And that equals 0. Okay, so when I solve for x, I'm going to put equals 0 everywhere I see an x. And I'm going to solve for both parentheses. So I think I need more space. Let's expand the page. So we got x minus 8 equals 0. So we're going to get left side, x side equals 8. And then we got x plus 1 equals 0. So subtract 1 on both sides, we get x equals -1. Okay, so we're going to trust that we did all the math correctly. We're going to trust that. I hope I did. I hope I didn't make any mistakes. Let me just check real fast. 2x plus 14, x squared minus 3x minus 2x plus 6, 5x positive 6 minus 2 minus 7. Yeah, looks good. Pretty sure I didn't make a mistake. So looks good to go. So all we're going to do when I check our answer is we're going to ask 2 questions this time, not 1. We're going to ask 2 because we have 2 restricted numbers. We have a restriction number for a 3 and a restricted number for a 2. So we're going to ask both of these x's, these values of x that we just solved for. Are you a 2 or a 3? And both of them are going to respond, nope, I'm an 8 and he's a -1. So we should be good to go. So when I write my answer on the line, we're going to put -1 and 8. Okay, so try to put your answers in numerical order. Just like your restricted numbers, try to put those in numerical order also. Smallest on the left, biggest on the right. Okay? And I think that's it. I think the next problem is part of homework. Yeah, it's part of homework. So good luck on this assignment, and I will see you in class. Bye-bye.